Okay, for today just have a few kind of random topic review slides that I want to make sure that you understand for the test tomorrow. Okay, chapter 3 is a big chapter, but fortunately you have the entire chapter on video. So please be prepared. Okay, me not being there is no excuse for not doing well in this chapter because you really have pretty unlimited resources. Okay. In section 3.1, we talked about scatter plots, how to make them, how to read them. We talked about explanatory versus response variables. Where does the explanatory variable go? It goes on the x-axis, and therefore the response variable goes on the y-axis. Sometimes the explanatory response relationship is a causal one, meaning x is causing y. Sometimes not. You need to know how to use the graphing calculator to make a scatter plot and to find the equation of the least squares regression line. Here, let me write that. Scatter plot, least squares regression line. To make a residual plot. And to find correlation. Those tutorials are all on the website, so if you've forgotten any of those calculator skills, go online. You need to know all about correlation. What does it tell us? What are the possible values? It tells us the direction and strength of a linear relationship, and the possible values are anything between -1 and 1. -1 means a perfectly linear negative relationship. +1 means a perfectly linear positive relationship. 0 means random scatter. What happens to the correlation if we reverse x and y? Nothing. What happens to the correlation if we change units? Nothing. The correlation is a standardized value. So the strength of the relationship between someone's height in inches and their weight in pounds is the same strength as their relationship between their height in centimeters and their weight in kilograms. The least squares regression line. How is it calculated? How do we find it? Well, there were 3 ways. What was the first way? Given data, we use the calculator. What was the second way? Using summary statistics, we use algebra. Remember, B is equal to R times SY over SX, and then we plug in the point X bar, Y bar. This is going to allow us to solve for the slope. This is going to allow us to solve for the y-intercept. And then the third is with the computer output. Do not forget that. What happens to the least squares regression line if we switch x and y? It changes, okay? There's not some shortcut for finding how it changes, but it would change. You need to be able to interpret the slope and y-intercept in the context of the problem. This is a big one, okay? There is a video for this. And finally, we need to be able to make predictions. In other words, plug in an x value to get a certain y hat. Remember, y hat is a prediction. You need to be able to calculate the slope given the mean and standard deviation. I think by that I just mean that B is equal to R times SY over SX equation, which we talked about already. You need to be able to interpret R squared. You need that R squared sentence. It also works the other way. Sometimes I'll say, what percent of the variation in da-da-da-da-da-da-da, in which case your answer is R squared. You need to be able to calculate residuals and look at residual plots. You need to know what they mean and how we use them. For example, with a residual plot, what is it that I'm looking for? I'm looking for no pattern. I'm looking for random scatter. If I see no pattern in the residual plot, that means I have a good linear model in my original scatter plot. I said, given a predicted value and a residual, can you find the actual value? Sure you can. Residual is equal to observed minus predicted, ROMP. So if I give you the prediction and I give you the residual, could you solve for the observed? Absolutely. Okay. You need to know what extrapolation is. Extrapolation is using an LSRL to make predictions far away from where the data is. It's bad because it's often inaccurate. A linear relationship may last over a certain domain, but then change either beyond or before those x values. So extrapolation is not reliable. You need to know the difference between outliers and influential points. Influential points are always going to be outliers, but outliers will not always be influential. You know it's an outlier just by looking at it. You know it's an influential point by removing it and seeing if the regression line changes. And then these last two, you need to remember that correlation is not the same thing as causation. And you need to be on the alert for lurking variables. Okay, X and Y aren't the only variables. There are other things that are influencing their relationship. Some reminders, properties of the least squares regression line. The least squares regression line changes if we switch X and Y. Remember, it minimizes the vertical distances. So if we switch X and Y, what was horizontal is now vertical, and so the line is completely going to change. I'm being redundant here, I'm sorry, but you need to be able to write the equation of a least squares regression line, either given the data, in which case you use the calculator, giving the summary statistics, in which case you use algebra, or using a computer output. Remember that R only describes the strength of a linear relationship, and R squared is the fraction or percent of variation in Y that's accounted for by the LSRL of Y on X. But do we leave Y's and X's in here? Absolutely not. We put it in context. Correlation and regression only work if we are talking about linear relationships. Extrapolations often provide unreliable or inaccurate predictions. And the correlation is not a resistant measure. This outlier right here would greatly decrease the correlation of this set of data, of this bivariate data. Some other, another list of topics that we've covered. I know I'm being really redundant here, but there's a lot that you need to study. Regression lines, predicting values, interpreting slope and y-intercept. The least squares regression line specifically minimizes the sum of the squared vertical distances. The slope is the correlation times the standard deviation of the y values over the standard deviation of the x values. Residuals are found by taking y minus y hat, the observed y value minus the predicted y value. Residual plots should appear random or patternless, and R squared is blank percent of the variation in y is accounted for by the LSRL of y on x. That is it for this chapter. I know that that review was redundant, but I really, really want to make sure you understand all of these concepts. For the remainder of the period, you can help each other on homework questions and help each other study for the test tomorrow, okay? I believe I left my teacher's edition of the book out so you can kind of see the answers to some of the even problems if you want to spend time on that. Otherwise, please be prepared for tomorrow. And we will begin the next chapter, which is actually chapter 5, the day after the test. Homework is due on the day of the test, don't forget.